So I'm going to be talking a bit about JSON Web Tokens, or JWTs, or on the Balkans we sometimes call them JWTs, or people are pronouncing that acronym JOT, or I've seen JUT, or I have no idea how that thing is pronounced, so I'm going to use all of them interchangeably. I think you will get the gist out of it, and mostly I will be calling them tokens. So, who am I and why am I talking about this thing? Well, I am Vekослав Stefановski. I work as head of development in Sorsico, Macedonia. I've been coding professionally for the last 2 centuries. I love programming. I love programmers. My 2 major professional goals are building better programs and building better programmers. So a domain that I love in development in general is authorization. Permissions, role-based systems, relationship-based systems, things like that. I've built a bunch of that. I love authorization. And when you get to do authorization, a lot of the time, the client, the manager, or whoever will say, oh, you're doing out. Let's put in, so you're going to do the authentication as well. And I kind of have to say, yeah, I will. Yeah, nobody else is going to do it, so I have to. If you want to do the out Z, usually you get stuck with out N. There are a few crazy people out there who actually love out N, but that's their problem. For those that didn't understand this part, authorization and authentication are oftentimes used interchangeably, even in specific literature. Authentication answers the question, who are you? And authorization answers the questions, what can you do? After we know. So usually for authentication in the real life, we all have a central system which we call the government, that has a ministry that issues some kind of documents that we use for authentication. And we have to do that kind of on the web. Those are my contact information. Feel free to live tweet at me. I'm that guy on Mastodon and on Blue Sky and things like that. I still don't have an OnlyFans account. It's coming. If you didn't know, there was a bit of crisis in the IT in 2023, so that might actually become a thing. Who knows? And what I will be talking about, I'll be talking about JSON Web Tokens, what are they made of, and how to mess up using them. All of the examples are basically a riff on something that I encountered in real life, in real project that actually worked or didn't work somewhere. And I will be talking about how to make a really insecure application using JSON Web Tokens, how to mess up the performance of that part of the system, how to actually slow down the whole system to a crawl. So, of course, you have to put an exclamation mark through all of this, because you actually don't want to do that. I'm just explaining how I managed to do it multiple times and how I've seen other people do that. These are our sponsors. These are the people who made this thing possible. And so, what do we have inside a JSON Web Token? If you remember one thing, aside from OnlyFans, on this talk, remember the first line. The JSON Web Tokens are not magical. Just because you are using JSON Web Tokens in your application doesn't mean your application is suddenly secure. Doesn't mean your application is better because of that. It only means that you're using a tool. That's it. So it's not an inherently secure approach. It's not a silver bullet, it's not magical. But what it is, it's actually just a bit of encoded text. So I have a few tokens lying around here. Yeah. For example, this is a token. And if you just see this, if most people see this, even most developers, oh, this is some heavily encrypted stuff. I have no idea what's here. Nobody can understand this. But Let's actually go to a site that's a relatively simple site. That's the code base 64. Yeah. So I'm going to take this part here. That's actually in front of the first dot. And I will just paste this here, paste this random unknowable text here, and click decode. So this thing doesn't know anything about my application, doesn't know anything about my token, and it was able to actually see that I have this text inside of it. And you've seen text like this. First of all, is everybody here a developer? Everybody here a JavaScript developer? Yeah, so you've seen this. This is a thing we call JSON. Yeah, so this is a string, and we kind of pretend there's an object inside of it. And we have a helpful method that can actually do that. So this is the content of that unknowable part. And I have another part here that we can also decode. And I'm getting a lot more stuff from this. And I'm getting, note that, again, I have no idea what's inside that test. The site that decoded this has no idea what's inside of it. It doesn't use any magical keys or anything. And it was still able to get all this data out of it. And this is a regular JSON. We can use this as an object, and if we are human, we can read the contents. Which means if you have a JSON Web Token, anybody that has that JSON Web Token can take a look at it. Whether they can verify it, it's another thing that we're going to come back to. But this is the content of these JSON Web Tokens, and the standard specifies some of the fields that we're going to have in the second part, which is the payload. So we're going to have who issued it, for whom it was issued. That can be the same thing, and that can be a different thing if we're doing SSO and whatnot. We have something called the subject that should contain something, usually it's the user ID. The exp should be the expiration date in the Unix time format, the issue that, because it's much better to call it IIT than issue that. And we can have other things inside of it as well. We can have custom data. Literally, the standard says that if you're using custom data, you're supposed to prefix it like this or like that, but nobody does that. So this is a common format of a JSON Web Token that you can actually see, not this one specific one, but you can see in the wild. And speaking of that, I mentioned that the token had, I didn't, but I showed it on the slide, that the token has 3 parts. And those 3 parts are separated by dots. So we have our first part, dot, our second part, dot, and then we have nothing. Well, here is where the secure part usually kicks in. But one thing that we should also note is that this token was actually defined using this thing, which specifies what, in the header we're specifying what algorithm we're going to use to verify or do stuff with the tokens. And I said that the algorithm that I chose to use for this token is the algorithm none. And that's a valid algorithm. So if we have a none algorithm, that means that my third part, which is the cryptographic signature, is empty. So is this token valid? It's definitely valid, because it has the correct signature, which is no signature at all. So this is a totally unsecure, a totally open piece of data that anybody that has this piece of data can read it, can manipulate it, can do things with it. And if I want to change something in it, what do I have to do? Change the data in the JSON, encode it. That's all I have to do. So I'll come back to this. So one of the first examples of mistakes that I'm seeing is that people are putting sensitive data inside their JSON Web Tokens. JSON Web Tokens can be encrypted, but in at least 99% of use cases, they're not. Which means that if you have sensitive data in that JSON Web Token, and that JSON Web Tokens got somehow stolen, anybody can read the payload. So what I did here, I am a developer, so of course I started developing. I'll have some data where I have some sample payload, and then I have some other sensitive payload that also includes sensitive information. Note that while the token itself, we can say, but this token expires. Yeah, but the password that's written here in plain text, in encoded text, will stay here. So the attacker might, if an attacker manages to steal the JSON Web Token, he might not be able to use it to actually hack our platform, but he can use the password, or he can use the credit card, or social security number. And another thing that I want to mention, that even in the best case scenario, when the user actually is the only one that's using the token, there are sometimes some system-sensitive data. For example, we might have user segmentation, and we don't want the user to know that he's, for example, shadow banned. If we put that information inside the token, the user can see everything that's inside the token, including that data. And this was a thing that actually happened a few months ago, when somebody was including system-sensitive data inside the user, and the user, well, if I decode it, it says that I'm an asshole, basically. That's not a nice thing to do. Because, again, somebody thought that this thing is magical and it's magically protected. It's not. So we have this sensitive data, and here I have some methods. This is code. This code uses no libraries, literally what is given to it inside from Node. So we have a to-base64 function. We have how to make an unsigned thing. We just, in a specific way, encode those things and put a dot between them. So this thing, encode, can actually get any thing, and it will just encode it and create an unsigned thing. So we can, I think I have, it's called make signed, make unsigned. So this thing just takes the data, the payload data, and creates an unsigned token, a valid unsigned token. And the next thing that we can do is we can sign those tokens. And note that this is a cryptographic operation, but just because it's a cryptographic operation, it doesn't mean that it's encrypting stuff. The text still stays in plain text. So what we will do, we will sign that data, signing it with a secret key. That's somewhere around here. Yeah. Don't tell it to anybody. That's my approach to security. You can see it, but please don't photograph this part. Turn off the camera. Yeah, of course, you're not going to keep your secret in the code. You're going to keep your secret in some secret management whatever. This talk is not about that. But we will have some kind of secret that we will use to sign our token. And then we can use the same, basically, code to create the signed tokens. So these are signed. Only I can verify that these are actually tokens that I made, because only I, okay, in all of you and the guys on the stream, can know my secret thing. So I'm going to use another site now that's called jwt.io, and paste this. So this site, again, doesn't know anything about my secret key. But still, it was able to get all the data. So this is a signed token. It cannot say whether this is invalid or invalid. Right now it says it's invalid because it didn't, I didn't paste it here. But when I do paste it, where was it? Yeah, it will say, yes, this is a valid token and it was generated by that thing. So I am able to verify it. So we have these tokens, but how are we actually using them? Usually, it's a general kind of process. And I have it somewhere. Nope. Yeah, that we can use. Yet another site that I love, sequencediagram.org. We can put in some text and it generates a sequence diagram. So this is the flow of generating and using a JSON Web Token. We have at least two agents, a client and a server, and the client says, here are my credentials. They don't have to be a username and a password. We can use Face ID, we can use all the fancy new things, 2-factor, 7-factor, whatever we want to do. But after all that song and dance, we don't want to force the user to go through that pain again. So what we do, the server generates the JSON Web Token using all the secrets that it has, and it says, here is a token. Save it and cherish it and use it on every request. So on each and every request, instead of logging again and getting an email, clicking the validation and all of that, they can actually say, I have a token. I am pre-approved, so to say. I have a token, and I will include this token with whatever request I'm making, and the server will get the token, and it will say, well, if you have this token, then I will give you your data. So it's not a thing that neither the server or the client actually need to have, but it's much easier that way. It's much easier that way, and then our user is somehow pre-authenticated, and it already uses that token instead of the password, which means that if the token gets stolen, what happens? The guy who stole it can impersonate the user, and to be honest, we're mostly fine with that. We're kind of assuming that the token won't get stolen, or if it gets stolen, we will have some mechanism that does something. This talk won't go into details of all the ways that's possible to steal your token and things like that. It will just focus on how we can mess up using the JWTs. There are lots of more other ways that we can mess up that include JWTs but are not specific to them. We would have been something like here for a week if we started going into depth on that. So it's generated by the server, but it's always sent to the client. The server generates it but doesn't need it. The client needs it. Always it's communicated from the client toward the server, and it should be verified on the server. No magic required. That's all that's supposed to happen. However, that's not what always happens. A lot of the time, and I've seen this at least twice, JWTs are just not checked, validated on the server. This is a thing that doesn't happen too often, but if you just see that they have a JSON Web Token and they say, you're fine, that's going to work. Or if you just extract the payload that has the user ID and say, oh, hello, Mr. Bill Gates. Because on the payload it says that it's Bill Gates. Why not? Or Elon Musk or whoever is your personal favorite. because the reasons for this is that validation is kind of cryptographically expensive, and the most common scenario for this is that we can have some complicated login mechanism, we have some weird things, and we have developers that just want to test something. So in the easier way to test something on staging or on dev or on Q or whatever your environment you have is basically to // comment out the authentication code and say, well, now I will work unauthenticated, but I will check the token and everything is okay because I can test my code and the validation is actually off. And then that code, of course, makes it to production. The scary thing is that this is still a fully functional system. If the users are using the system as intended, this can go on for quite a while, because all of the other things work. Three-factor authentication works. Everything is okay. You just need to basically go in and manually edit the token to expose this. And this is the scenario that is usually not covered in regular functional testing. We will check whether a user can log in with the wrong password. But we might not check whether a user can log in with the wrong token. So, of course, I wrote some code about that. So here we have our server, and here is our verification method. And the verification method will be something along these lines. We're just taking the token, we're getting the payload out, and that's it. We're returning the payload. So just any token that we receive is going to be treated as a valid token. And most of the cases, we will get a valid token because the user did log into our application. So, if we use it with the good token, it will work. But what happens if we use it with a token that's not so good? That somebody just went in and edited this. He managed to get in as an admin. But this kind of required access to the secret, so he generated his own token. That guy, our admins usually can mess us up. But what can happen here? Note that this doesn't actually call the encode sign, doesn't need the signature, the secret. It just needs a token. It takes the good token and replaces the payload. And if our system does that, here we have, yeah, you are a valid user. You are Dr. Evil and you are an admin. Here is your system. Yeah. This, to be honest, doesn't happen too often, and usually is because of bad code practices. Because in order to test it, we will disable it, and then nobody noticed that it was disabled, and it just worked. So we should have some kind of a security-minded tests that that cover this. Because this is trivial. If you take a look at the code, it says, yeah, we're not running the verification. That said, even if we do run the validation, we have cases when we do it, but in a bad way. Again, JSON Web Tokens are not magic. We create them, and if we create them using an algorithm, when we get a token, we have to check that we are actually getting the same algorithm back. And if we're using asymmetric keys, we need to use we need to check that it's actually done in the right direction, because there have been attacks when the user actually signs the key, but using the public key. And then the system says, well, it's an older code, but it checks out, basically. So we need to be careful that the tokens that we validate basically look like tokens that we created. Because in general, they should be only tokens that we created. Nobody should be allowed to just create another token and ask to verify it. It should be always. And now somebody will say, well, how about we make a list of all the tokens and keep it on the server? And that's actually point 5. We'll get to that. Because tokens are supposed to be stateless. So we don't know which tokens we created, but we should be only able to verify only tokens that we created. So it's a bit of a chicken and an egg problem. Again, we have some code about that. So here our server will actually take, is it the correct one? Yeah, it is. So we're taking the header and the payload again, but now we're passing the whole token using our secret key as well to our verifications thing. What is our verifications things? Basically, it's a set of methods that will verify different algorithms. Because usually it's not us that's going to be writing their code. We're going to be using a library to do the verification. And the library will do the verification for all the algorithms. It's not going to be a special library for one algorithm, special for another, and so on. So all the libraries will have that. It's the caller, you, who should be responsible to actually say, if I'm using HS256, then check that this token is actually signed using HS226. But here we have our verification, and it says if we don't have an algorithm, then the token is valid. None is always valid. And if we have HS256, do this kind of validation. So the good token passes the validation, because the good token has the signature, that signature matches our secret key, everything works great. The bad token. The bad token is actually an unsigned token. Anybody can create that. They just use 3 lines of JavaScript. Anybody can create that token, and our system says, yeah, sure, he's an admin. Why not? And the ugly token, of course, is the same thing, only this is an external user. So we can both get privilege escalation and we can get user impersonation using this. Because somebody who's not that user can claim to be that user, and somebody who's not an admin can claim, well, I'm an admin. It says right here in the token. Yet another thing that actually happens more often than this. Yeah, and just a second. This is, again, specific to how you are using the libraries. You're using the perfect library, but if you don't instruct that library to actually check for the algorithm, it's not gonna. And recently there was an attack using JSON Web Token, I think it was actually called, the library that allowed none by default. And they had a PR that actually removed, so now none is only supported if you explicitly allow it. But for about 5 years that library existed, none was allowed by default unless you explicitly excluded it. So you cannot rely on the library that the library will solve this for you. You need to check it. If it does, great. If it doesn't, do it yourself. Yeah. One other thing that I see all the time, and most of you are guilty of this, is bloating. Because the JSON Web Token is a nice piece of data that is always there, that is sent back and forth, that we have it all the time, which means that if we want to have some state somewhere, we can put it in the token. It's a nice place to put stuff. And it's a JSON object. We can put whatever we want. So those tokens will be used as headers or as cookies. Those things are limited to 4 kilobytes, to 8 kilobytes, which is a significant amount of text, but it's not an enormous amount of text. And they are transmitted each and every time the client uses our application. In a modern web application with lots of APIs, you basically look at the application and it makes 30 network requests. And each of those 30 network requests will use that token. The token will get transmitted again and again and again. And if we made our server properly, it will be verified again and again and again. It's not the most expensive thing that you can do, but it's not free. Cryptography takes some time. So we are actually slowing our application significantly by bloating the token. And of course, if we overbloat the token, we get a lot of fun things happening, actually. With a bloated token, you get a lot of HTTP responses like 431 or 419 or things like that that you didn't know existed. That happens if you get a cookie that's over 8 kilobytes or a header that's over 8 kilobytes, depending, and it's not going to happen each time. It's going to happen for some users on some browsers, sometime, and it will be, oh, this happened, refresh, now it's okay. And those are fun times to debug. So this is based on what I've actually seen. So this is a relatively normal payload, but this is kind of bloated. So I've seen order history inside the token. Why? Because it's a nice place to put it. You have it all the time. And then your basket is always up to date. It's not its place to do here. Or, alternatively, I've seen all the user data, the complete user profile, which can be huge. Fortunately, this thing doesn't, any significant image will be over 4 kilobytes, so I haven't seen images included in tokens, but I know that I will see that eventually, that somebody managed to use an avatar inside the token. So we have all the user profile just put inside the token. No, use the minimal thing that you actually need. It doesn't, if you use one thing once, that's okay. But it's a slippery slope, and a lot of people have fallen down that. So if we generate the tokens for those, nope. CD. And we can make them the signed tokens. So the regular one is just 337 bytes. Tokens are relatively big anytime because we're using base 64 and we're using JSON, which are not the most compact formats. But still, that was 300 bytes, and this is over 2.5 kilobytes. And if we have something like this, this will be transmitted, those 2.5 kilobytes, multiplied that by 1 million requests a day, that's a lot of bytes. And somebody's going to pay for that. And now we're getting a bit on the nitty-gritty. As I mentioned, JSON Web Tokens are not magical, and we don't have any kind of, since they're supposed to be stateless, that means we don't have a revocation mechanism. We cannot say this token is no longer valid. What we use as a crutch is the issued ad, is the expiry date. So we can each create a token, and usually if we are talking about accessing a system, we will create a token that's just valid for a tiny amount of time. I prefer something no bigger than 5 minutes, which means that token is usable, a user can use it, and after 5 minutes pass, I will see that that token is expired, I will throw that token away, generate a new token for the user, and then have him use it. I'm not going into how the refreshing mechanism works, that's a whole another lecture, but it's always nice that when that token is stolen, it will only be valid for 5 minutes. For 5 minutes, nobody can actually exfiltrate a lot of data. It's not the best scenario, but still, it's better than having that token, as I've seen, live forever. Why not? It's a token. And by using a token that lives forever, what we've actually done is make things worse. And I've seen a lot of tokens that either last forever or last for at least for a month. That means that if an attacker manages to actually steal that token, they have free reign, and we cannot stop them in a forever token, because that token is going to remain valid all the time. We're going to have to basically rebuild the server and change the secret or something like that for that token to become invalid. And usually when a token is stolen, the attacker is not going to say, hey, I stole your token. No, they're just going to use it, and we're going to say, it appears that this admin user is using a lot of data recently, or something like that. And one other thing that I've seen do is the order of validation. Sometimes we receive a token, and we see that the token is expired. And the logic goes, oh, this token is expired, that means that we need to refresh it. And we refresh it. But we check whether the token is expired before we check whether that token has a valid signature. Which means that if an attacker actually comes at us with an expired token that is also invalid, what are we going to do? We're going to refresh it. So it actually gave us an invalid token, and we gave it a valid token back. That's like going to, what's your biggest, I don't know, TV store or something like that. You're going to a TV store with a broken TV. Oh, I just bought this yesterday and it broke. Can you exchange it for a new one? And they say, oh, okay, immediately. And they don't check the receipt. They only check the receipt after that. And this is a tricky thing because it happens relatively often, and it's not obvious. Most of the other code that I've shown is kind of obvious when you take a look at it, but whether this happens, it's not always obvious. So for example, here I have that validation. All of the code is totally valid and totally sane, taken piece by piece. So we're getting the payload, we are seeing whether the expiry has passed. If the expiry has passed, we are saying that this is not a valid token because it's expired. And then we run the verification, and if the verification is not valid, we say that this token is invalid because it has an invalid signature. So this method won't allow any token that is not valid to pass through it. It will say, no, this token is invalid. Great. But what happens next? Next we have, was the validation successful? If it was successful, well, congratulations, you're logged in. But if it wasn't successful and it was expired, we're going to generate a new token and return that and log the user in. So what happens here? 4. Yeah. The other way around. We use the good token. It just works because this is not an expired token. If we use the bad token, that is also a token that was expired, but let's see if that's the example. This is just a token that's immediately expired because it expired at the beginning of time in the 70s. And we're sending it that. The system sees that it's expired and refreshes it. And the user not only is logged in, but has a fresh valid token that we created. Oh, sorry. And now we managed to log in Dr. Evil because he also had an expired token. He managed to get a hold of a real token and created an invalid token out of that. But it's automatically expired. And worst of all is something like this that I've seen on the wild. This token is for a valid user who is validly an administrator and everything is great, but this token will actually be valid until the end of time. We all know the world ends in 2038, right? That's when time ends, officially. One more thing that I said that I'm going to talk about is this thing. JSON Web Tokens are supposed to be stateless, that we are not supposed to have a lot of server infrastructure that actually manages. If we're using state, we might as well use session cookies. We might just send a GUID to the user and then use that GUID as a lookup into something. That's why it doesn't make sense to have a list of all the tokens we generated on the server, and then when a token comes along, we don't need to verify this. We can just look up in the list of valid ones. And basically, you're using something that's a 1 kilobyte thing to serve as a 120-byte GUID, bit GUID. So you could have used a 16 bytes for that. You don't need to use a whole JSON encoded string and whatnot. If you need to check through a list, if you need to do that. So stateless authentication is not really a thing that can work end-to-end. There will be some state. But it is our goal, it is our duty to actually make that as stateless as possible. So if we're using token, the goal should be to work stateless. We might have some kind of a blacklist that we consult, but the blacklist should have something like 3 items on it, not 10,000. We should be able to use some kind of verification, additional verification, whether that makes sense. But that verification shouldn't rely on too much external state. In general, we should not have a database call in our authentication. Well, the major reason here is that this thing happens each and every time somebody looks at your application, somebody uses your API. So if you have 30 database calls that average 1 database call each, you think that you have 30 database calls. But if you add just a single database call inside your state check, authentication check, that means you suddenly get from 30 to 60 database calls. So this thing will actually double the amount because it happens each and every time somebody looks at your application. We actually had a client that kind of had a great idea that they should be very secure and use a different key for each user. That means they generate the key and then they save the key to the database, which means when the user logs in or when we need to check the user, we need to go to the database, get the user. And another thing I've seen is after we get the key, and another thing that I've seen is that after we verify the user, we just get the user ID and then go to the database to load the whole user profile that has the roles and everything and whatnot. And that means that we have several database calls that occur each and every time something happens. And that can be up to, from what I've seen, up to between 30 and 50% of what your application does. Is just checking tokens and again and again and again and again. So don't use this thing as state. That's why we want it to be stateless. So we don't have to have any lookups. And even if we do some lookups, those need to be cached, those need to be fast, because your authentication code, authentication verification code, will be used a lot. Will be the most used code in your application because it's impossible, if you build it good, it's impossible to use any part of your application without going through it. So it is performance critical. And it is also at the same time security critical, which are kind of at odds with each other. So yeah, let's repeat the fourth example, but this time we have a lot of state management. So we're going to fetch the user, we're going to fetch the key for the user, and after we fetch that, we're going to fetch the user profile, and you can see that now I'm printing a better message. It's not user John Doe, it's the user's John Doe. We know his name and last name. We can greet him better because we loaded the profile, which unfortunately took some time that we're going to waste each and every time that we actually call this. And it still doesn't mean that we're actually secure. Yeah, and the user here is Dr. Evil. We will fetch it. We will see that there is some problem, and we will be able to log it. But we will be nice to our hacker, and we're not going to use the username. We're going to say his full name and last name, which I recently found out is actually Douglas Powers. Yeah. So that's about all I had. If you have any questions or comments or complaints or whatever, feel free to live tweet at me, feel free to ask me. I will be here all day, or you can just raise your hand right now. Sure?
It's about practice to have a lot of data in the token. Can you hear me? Yeah, okay.
Yeah.
You said it's about practice to have a lot of data in the token. Let's say we have an admin token that contains the roles of the admin. And let's say the roles are like 100, 150. Is that a good practice? Is that something someone uses a lot?
I've seen that, and it's not supposed to be a 150. With three, I would be totally okay.
System.
Yeah, I would totally be okay to have. I'm going to go into an authorization round, but in general, I would be okay if we set up something like up to 3 or 4 or 5 roles, something that fits on a slide, as Radi would say. But anything above that, or if it's just one guy, that is the extreme example, but I would want my average to be something like 3 or 4.
We're talking about a really complex system that has a role for each endpoint that it uses, and that's why it has that many roles.
Yeah. Again, that's beta authorization.
That's beta authorization. How I'm a quality assurance specialist, so how I can present that to the people who are making it? Like, how can I tell them it's bad? I just can't go in. You're an idiot. No,
yeah, I'm trying really hard not to go into the authorization round, but I will later offline. Basically, you need to. In most of the cases, you need to change from role-based authentication to relationship-based authorization. So that you can have basically what you want to do with that system explained and not have a role per endpoint or something like that. Role per endpoint is not a role, that's a permission.
Yeah, we're talking about permissions.
Yeah, so basically you don't have roles, you have just something that you call roles.
Yeah, we actually have like group of permissions, and they're listed alongside the roles, alongside the permissions.
Both of them in the token?
Yeah.
That's extra data. That needs to be trimmed.
Yeah, so we're talking about here the
that's
amount of
definitely
data.
bloating.
That's bloating, okay. Yeah, it's something that, okay, I'm fighting this. First thing Monday. Thank you so much.
Yeah. Okay, I will be here. You can.
Just one question.
Sure.
Where is the best place to store a JWT token? In a mobile application and in a web application?
I'm talking about web. I'm not touching mobile. Mobile is way more complicated because you only have the client.
Yeah.
There are special set of worst practices for mobile.
Yeah.
But on the web application, I kind of prefer it in a cookie because I can make sure that the cookie is not accessible to JavaScript. If I store it in local storage or anything else, basically it has to be accessible to JavaScript, which means that it's vulnerable to any kind of injection attack or something like that. But if I store it inside the cookie, I can just say, this is an HTTP-only cookie, and I can make sure that I get it every time, and that nobody else gets it. So that's my personal preference. You will find definitely a talk on the internet that says, no, using cookies is stupid, use session state or something like that. And for a mobile application, I'm refusing to answer that because I'm not sure. Whatever I say, it's going to be wrong.
Okay. Where can I find you to ask you more about the mobile and PKC afterwards? Where can I find you to ask you about the mobile? OnlyFans. Okay.
Yeah. Now I have my contact info here.
Okay.
Yeah.
Thank you.
The presentation, the code I've shown is already on GitHub, so you can take a look at it. This is LinkedIn, YouTube, Twitter. Yeah. I'm relatively easy to find. Thank you.